Here are some examples of using the properties of exponents to simplify these expressions. So what we have in this first example is 3ab to the fourth times 4ab to the negative third, and we're multiplying these two expressions together. If I drop the parentheses and try to just combine like pieces, I'm just going to put the coefficients together first, the 3 and the 4. And then I'm going to combine the a and the a together. Those are common bases. And then I'm going to combine the b to the fourth and b to the negative 3. Now, 3 times 4 is 12. A times a, if you remember, this is a 1 and a 1, so you can combine those together as 1 and 1, which is a squared. And then I still have that 12 out in front. And then the last one, b to the fourth and b to the negative 3 are the same base, so you can add them. So b to the fourth plus b to the negative 3 is b to the 1. So we added those exponents together because our bases are the same and they're multiplying. This next example, we want to distribute that power through. So power goes through to all three pieces. So it looks like this: 2 to the third, x to the third, y squared to the third. Now let's do some cleanup. So in the blue term, we have 2 times 2 times 2, which is 8. And then in the red, we have x times x times x, which is x to the third. The last one, y squared raised to the third power. If you remember, that is a power to a power rule. It is y squared times 3. We multiply those together. So we get y to the 6th. And then the last two terms are still the same that were in front. Here's a couple more examples. We want to simplify example C. Now let's look inside of this parentheses. This parentheses is raised to the 0 power. If you remember, anything raised to the 0 power is 1. So this whole piece becomes 1. And then I still have this 3a. So 3a times 1 is 3a. Coming over to example D, what we have here is 5x cubed divided by y, and everything is squared. So I'm going to distribute a 2 power to all three pieces. So let's take care of this first piece. So 5 squared, x cubed squared, and then over y squared. Now let's do some simplifying. So 5 times 5 is 25. If you remember, what happens with these two, this is a power to a power rule, so we multiply those together. So 3 times 2, and then still just y squared. Our last piece is to multiply the 3 times 2. 3 times 2 is x to the 6th. And then we have 25 over y squared. Example E. This is x to the negative 1 power. If you remember, anything raised to the negative 1 power can be written as a fraction. So now it would be 1 over x to the positive 1 power. This example is pretty close. we still have this piece here that has to go up, but we're going to leave the positive 3 alone because there isn't a negative power there. So I'm going to leave the 1 and the 3 alone, and now this blue piece is going to come up as a positive x squared. Now it is x squared over 3. Example G, we have some negative powers here. I'm going to bring this negative power down. I'm going to bring this negative power up. So let's just leave the pieces alone that are not moving. So 12a cubed over 4b. Now this, just erase this for a minute. This b to the 4th is going down because it is a negative power. And then this a to the negative 2 is going up to make it a positive power. Now we can go ahead and do some simplifying within that parentheses. So within that parentheses, I'm just going to, not the parentheses, the expression 12a cubed a squared over 4b b to the 4th. I'm just rewriting it again. Now let's take care of the coefficients first. We can simplify the coefficients. We can divide both of them by 4. So 12 divided by 4 is 3, and 4 divided by 4 is 1. Then, in my numerator, I have an a cubed times a squared. Well, this will become a to the 5th power. And then in the denominator, I have a b to the 1 times b to the 4th. These can combine together to be, adding them as b to the 5th. And then in the numerator, it is 3. In the denominator, it was 1. And that's what my answer looks like. You don't need to have that 1 there if you don't want